Welcome back, everybody. I hope everyone had a good weekend. We're going to continue on section 1.3 continued and hopefully get through a lot of 1.4 to play catch up. So, dimensional analysis. Which is really just a fancy name to say unit conversions. Dimensional analysis, that's the way you can refer to it as your friends. Oh, I study dimensional analysis, and then that can intimidate them. Unit conversions are probably one of the most fun things you can ever do in your life, in my opinion. I mean, granted, I'm biased. Probably not actually the most fun thing. I mean, Pokemon is pretty fun. Not that I've ever played, but either way. But this thing, like, I'm a big fan of nuance. I love nuance in life. I think nuance is what makes life important, right? You go out to a park, that's not a lawn, that's a field. I've noticed that with my son. I have to that fire is not dwindling, that's an ember. Like all these stupid words that we say just to mean specific versions of things, nuance. And dimensional analysis allows you to do that all the time. So, first things first is a definition. A conversion factor aka unit fraction. The book calls it a unit fraction. I think conversion factor makes way more sense. But a conversion factor or a unit fraction is a fraction used to convert, to change from one set of units to another. The value in the numerator, is that okay with NUM to mean numerator? So NUM meaning numerator. The value in the numerator should be quote unquote equal to the denominator, to the value in the denominator. Now I put equal in quotation marks because equal doesn't make, like, not in a mathematical sense, but in a real world sense. And so I'll give you an example. I'll give you 3 examples. You've seen them all the time. You use these without even realizing it. So some examples. I'm going to do, so I'm going to say the conversion factor over here. So the first one is that 12 inches equals 1 foot. Right? We know that 12 inches in a foot because this is America and we like, this is America and we like to use our silly measurements. Yes, 12 inches in a foot, 3 feet in a yard, 5,280 feet in a mile, because that makes sense, right? That's clearly a totally awesome calculation that everyone can easily memorize. 5,280 feet, that's a very easy number to memorize, right? Totally. No, we Americans, we can't handle much. So the conversion factor. So when you say that, that means you could write it as 1 foot per, because division symbol can also mean per. So 1 foot per 12 inches, or you could write it in a different way. You could write it as 12 inches per 1 foot. Depending on the situation, if you want to convert from inches to feet, you use the first one. And I'll explain why and how in a second. Or if you want to convert from feet to inches, you use the second one. So that is one example of a conversion factor. Another example, and this was very, very useful if you're a baker or if you like to cook, is that 3 teaspoons equals 1 tablespoon. Fun fact. So that if you need to have a half a tablespoon, like granted, I lucked out and my set has a 1/2 tablespoon, but another way to do that would be to do one teaspoon and then a half a teaspoon. So that would be 1/2 a tablespoon. Very, very useful. So the conversion factor would either be 1 TBS divided by 3 teaspoons, TSP, meaning for every 1 tablespoon, there are 3 teaspoons, or 3 teaspoons per, not TPS, TSP, divided by 1 TBS. 3 teaspoons to every 1 tablespoon. And the last one that doesn't look like a unit conversion factor would be something like 60 mph, miles per hour. That is a conversion factor. What that reads as is there are 60 miles for every 1 hour traveled. Or for every 1 hour that you travel 60 miles. However you need to use it, because depending on the situation, you might use the other one over the other. And hopefully the examples that I'm about to show you are fun and enlightening to show you how you can use this in your daily life. And be the belle of the ball, as they say. So the key to doing unit conversion problems is that if a unit measurement is in the numerator and denominator, it cancels, quote unquote. So we want to cancel any unwanted units by multiplying with conversion factors until we're left with only our desired units. Only the units that we want. Whew, a lot of writing. So we're going to do some quote unquote basic ones, meaning that these are just going to be immediate calculations, and then we'll go on to some word problems to make it more fun. And I promise you they will be fun. I like this section a lot. For to show you how you can use this, you can use this to figure out how many calories are in your in a serving of a new recipe that you're trying. You can use these to calculate how many calories there are in a cup of cooked rice, because if you've ever looked at a bag of uncooked rice, it says calories in 1 cup of uncooked rice. Oh, that's great. I'm going to eat it raw. I'm going to eat just hard rice. Yeah, that's a great idea. No, I want to know how many calories there are in a cup of cooked rice. And they never tell you that. They never tell you that. So legitimately, my wife and I sat down, because this is what we do, because we're super fun people. We figured out how much a cup of cooked rice was based on based on conversion factors. But anyways, example. Let me just skip to the next page. Is it okay to move? You good? Okay. Wait, people still ready? Okay, cool. Wait. Just passed by multiply, so like right there's good. All right. So example, convert and round to nearest hundredth. Hundredth meaning, so it goes tenths, hundredths, thousandths, 10,000. So rounding to the nearest 2 decimal places. Part A will be 100 yards to feet. You good? Okay. 100 yards to feet. Part B will be 5 miles to yards. C will be 45 miles per hour. So freedom units to them damn Canadians, to kph, and also our so kph our neighbors above and below us, the smarter ones, and across the pond and everywhere else. What's it? Kilometers per yes, kilometers per hour. And then last one will be D will be 20 miles per hour to feet per second. So I'm going to show you the formal way, and then I'm going to show you a nice quick way, a little more organized way to do it, because there's a little bit easier thing to do. So part A, we're going to start with that 100 yards. And we want to convert that to feet. Now, I know a conversion factor from yards to feet, right? And feet to yards. There's 3 feet in every yard, right? Now, you can do this pretty quickly in your head if you want to. If it's not too hard, great. Otherwise, what we do is we multiply this by the fact that for every 1 yard, there are 3 feet. So 3 feet per 1 yard. I put it like that, and I'll show you why. One thing that mathematicians use all the time, it's a very, very useful tool in mathematics, is that anything can be written as a fraction. Anything can be written as a fraction by writing it as over 1. Not a very exciting fraction, right? Because dividing by 1 doesn't do anything, but it's still a fraction now. And the reason I've done this is that now there's a yards in the numerator and there's a yards in the denominator. So yards in the numerator and there's a yards in a denominator. So then the yard units cancel. And so now all we have are feet, which is what we want. We want the answer to be in feet. So after each unit conversion, you want to stop and see if you have the desired unit. We do now, we just have feet, which is exactly what the question is asking for. So one thing to know about fractions is that when you're multiplying fractions together, you multiply the numerators together and multiply the denominators together. So this becomes 100 times 3 divided by 1 times 1. You don't need to write the 1 times 1 if you feel comfortable, because there's dividing by 1 and multiplying 1 that don't do anything, but either way, and it's going to be all that's left are feet. So that's 300 feet. That is our answer. And because there's no decimal, we don't need to worry about rounding. There's no hundredths place, so it's already rounded for us. Now, that's one way to do it. I'm going to show you now the the nicer way, but you can still do it this way if this makes more sense to you, or if you've done it this way your whole time, continue to do it that way. That's fine. Still mathematically valid, but I want to show you a different way that might help a little bit. I find that especially with longer unit conversions, this helps me keep it organized. So we have 5 miles. And and it's not a fraction, so I'm going to make it a fraction, and I'm going to draw a giant horizontal line. And then each vertical line that I draw is going to represent a multiplication by another fraction. So I want to convert 5 miles to yards. Now there is a one-to-one conversion. There is a 1 conversion ratio to convert yards to miles. There is, but I don't know that off the top of my head, and I don't think anybody really does. If you do, kudos. That's a really niche piece of information that will never really be brought up in the real world. But I know the 1 conversion for feet. There are 5,280 feet in 1 mile. So there's 5,280 feet equals 1 mile, right? Now, should the miles go down the bottom or in the numerator?
Bottom.
The bottom, because I want them to cancel. So I know there is 1 mile is equivalent to 5,280 feet. And I'm going to stop and cancel the miles, because the miles now cancel because they're diagonal from each other. There's one in the numerator, one in the denominator. Those cancel. And so as it stands right now, I just have feet. I just have feet now. But that's not the answer. The answer needs to be in yards. So I need to tack on an additional unit conversion. Here, I know that there are 3 feet in 1 yard. So should I put the feet in the numerator or in the denominator? Take a second. Denominator, yes. Because I need to cancel the feet. So I need them to be diagonal from each other. I need 1 on top, 1 on bottom. So I'll put the 3 feet down on bottom and the 1 yard up top. Then I stop and I cancel the feet and I ask myself, do I have the desired unit measurement? Yes, I do. I have feet, I have yards, which is what I want my answer to be in. So you can do this in a lot of different ways. I recommend writing it out. So you can write 5 times 5,280. We can write multiply by 1, but remember, multiplying by 1 does nothing, right? If you 5 times 1 is still 5. 3,000 times 1 is still 3,000. And same thing for dividing by 1. It doesn't really do anything, right? 5 divided by 1 is still 5. So up top, we got 5 times 5,280. And down at the bottom, we just have a 3 yards. And so plugging that into my calculator, because I don't want to do that in my head, you should get 8,080. Yes, 8,800. 8,800 yards. Being said, though, once again, if you like the version that I did in part A, continue to do that. That's fine too. I just like the fact that this kind of, I get all the space that I want because I just write a giant fraction, a giant line for all of my fractions. And that way I don't have to keep drawing the same lines over and over again. And it keeps it nice and organized. But either way is fine. So C, 45 miles per hour into kilometers per hour. Does anybody know how many kilometers there are in a mile?
Like 0.6.
Very close. 1.61.
Oh.
So you got the 0.6. I'm very impressed with that. I don't know that off the top of my head. But so as a note, 1.61 kms is equal to 1 mile.
Oh, right. The kilometer.
Yes. Oh, yes. Just like the reverse direction. Like you can also write this in a different way. You could say that there's like 0.62 miles in every kilometer, or so whatever it is.
Right.
You could write it in a different way.
Oh,
There are two different ways to interpret it. And that's the reason for that is that this is one thing we do need to understand is that kilometers to miles is not a perfect ratio. It's not a 1-to-1 ratio. This is an approximation. I can't remember where it is in your textbook, but there should be a chart in your textbook that has all the important unit conversions. And on the exam, I will provide that. So you don't need to worry about like memorizing unit conversions. I will provide a chart with all of them. Save for maybe the like 60 seconds in a minute, 60 minutes in an hour, like some of the more obvious ones. But then again, you can always ask. Worst thing that can happen is I say no. So we have 45 miles in every 1 hour. And so we need to convert that to kilometers per hour. So we already have the hours down in the denominator. So we don't need to mess around with the hours. The only thing we need to get rid of are the miles. So because the miles are in the numerator now, I need to cancel them with miles in the denominator. And we know that for every 1 mile from above in the note, 1 mile is 1.61 kilometers. So we get rid of our freedom units and we're left with kilometers up top and hours on the bottom, which is exactly one. We want kmh or kph, kilometers per hour. And so this will be 45 times 1.61 divided by just 1, but you can leave it like kph. And that should be, where's my calculator? 72.45, yes. 72.45 kph. And that number only had 2 decimal places, so we don't need to round. If there was a 3rd decimal place, then we would round. But since it's only 2, we can't really, there's no number to look at to round to. Any questions on that?
And that's 45 times 1.61.
Yes, that's correct. Whenever you have a decimal, I recommend writing it as like that brings up a good point. Whenever you have a decimal number here, I recommend writing it as in parentheses, because otherwise it looks like this. Look, if you're not careful, or like kind of looks like it's 45 times 1 times 61, right? Which could cause some problems. So I recommend writing in parentheses to make sure you know when you're looking at it, especially on paper, maybe fine, but when you're going back and forth between looking at a problem on the homework on your computer and back down, it's easy to get lost. So last one, D. We want to convert 20 miles per hour, 20 miles for every 1 hour. And we want to convert that to feet per second. Now, the great news is that this is all multiplication, right? It's all being multiplied together. And multiplication is what we call commutative and associative. Commutativity just means that, like, you don't need to write this down, but commutativity just means that 2 times 3 is the same thing as 3 times 2, right? Doesn't matter how you multiply, as long as you multiply, it's good. And then associativity tells you that 2 times the quantity 3 times 4 is the same thing as 2 times 3 times 4, meaning that it doesn't matter which things you multiply first. So with those 2 properties in mind, it doesn't matter which ones we do first. And in this context, the reason why I'm bringing that up is that this means we can either convert the miles to feet first, or we can convert the hours to seconds first. So it doesn't matter which one. You guys want to convert the miles first or the hours first? Miles. It's on top, probably best. So we know, once again, there are 5,280 feet to a mile. So 1 mile, I'll put in the denominator, is equal to 5,280 feet. And so that cancels the miles. And now, if we were to read it, if we were to stop right here, we would have feet per hour. But that's not what we want. We want feet per second. And why do we want feet per second, by the way? That's usually a better indication of things like in physics, we like to see things in feet per second, or even maybe ideally meters per second, or nanometers per nanosecond, whatever. But anyways, so we need to get rid of those hours and convert them to seconds. Now there is a conversion ratio directly from hours to seconds. If you want to memorize it, I'm not going to provide it because I think it's a really, really niche one. Is there are 3,600 seconds in 1 hour. I'd rather us just convert it the easy way, which would be converting it to minutes first and then to seconds. So should the hours go up top or down bottom? On top, so that there's one on each, so they can cancel. So for every 1 hour, there are 60 minutes. And the hours cancel. So now we have feet per minute. Those are the only units left, feet and minutes. But we want feet per second. So we'll add on one more fraction. We want the minutes to go away. So for every 1 minute, we'll put the minutes up top so that they can cancel and get 60 seconds down and bottom. And so we see the last one, the minutes cancel, and all we have left is up top, we have the unit measurement feet, and down on the bottom, we have the unit measurement seconds. So we have everything we need. So up top, we're going to just have 20 times 5,280. We could write times one, but that won't change anything. That's why I don't have that there. And then down at the bottom, we have 60 times 60. And plugging that into our calculator, or if you do plug it into your calculator, make sure you've written it as a fraction or put your entire denominator in parentheses. So that will be, or you can calculate it separately. That's 105,600 divided by 3,600. And that will equal 29.333 repeating. So if we're going to approximate to 2 decimal places to the nearest hundredth, we're rounding here. So we look at the number to the right of it. It is less than 5. So we will round down and write 29.33 feet per second. Any questions on that? Okay. So that's how we do unit conversions like for the basic ones. Now we're gonna have a little bit of fun. But Phil, we've already been having. Exactly, guys. Exactly. I'm glad you agree. So example. Now this one is near and dear to my heart because this is actually something that's legitimately happened. This is 100% real. So if you plan to go into grad school, depending on the subject that you're interested in, one of the things that you have to do is you have to take the GRE, which is like the big boy SAT. And then you also have to take the subject GRE. So mine was the math GRE. And it's usually a lot, it's a smorgasbord of all the topics of your field. So if you're talking about, if you want to get a PhD in English, you'll probably have to read a bunch of books and know how to respond to those things and write some good essays. I don't necessarily know how the English GRE is, but the math GRE had 50% calculus, 25% linear algebra, and 25% other topics. And so what I did is I was planning to take that. Oh no. I will charge how much battery is left on my iPad. Sorry, 1 second. 45%. Okay, so I can just do some back and forth thing. So I was planning to take it at the end of the summer. So I spent the entire summer studying for the GRE, for the math GRE. And while I was studying, I was just looking through my textbooks and doing practice problems and stuff. And in order to make sure that I wasn't getting just because this is how I like to do things, I was watching a TV show in the background. In particular, I was watching Law and Order SVU, because that is the show that my mom and I connect over. We just, like everyone else in my family, hated that show, but Detective Stabler was my guy. He was a loose cannon cop who didn't play by the rules. He should have been fired like 100 times over. The guy is a loose cannon. But love that show. And over the course of the summer, I watched every episode of Law and Order SVU at that time period. They've increased the number of seasons. But so this is the prompt. Over the summer, Phil watched every episode of Law and Order SVU. There are 24 seasons. With 22 episodes each. If each episode is approximately, so like every episode is a little different, right? Some of them are a little a little longer than others, but on average, they're about 44 minutes. If each episode is approximately 44 minutes, so they can bust out 16 minutes of advertising to us, yay, capitalism, is approximately 44 minutes. How many days of Phil's life were wasted? So, and this is something I hate to bring up at parties. This is a fun little fact. I become the belle of the ball. I like to mention this. Everyone thinks I'm hilarious. So, but this is something I legitimately did. I also did this at one point in my junior year. They called it the snowpocalypse in Washington, because there was a massive snowstorm and everything shut down, and we actually got a week worth of class canceled. It's awesome. Some people that I knew were drank to the snow gods every time. However many days that were canceled that day, they would drink several additional alcoholic beverages to see if they could get another day of snow canceling. And during that time period, I used it very, very wisely. I watched every episode of Battlestar Galactica, of which there are 4 seasons and 22 episodes in each season, each one running 44 minutes. But anyways, this is a unit conversion. You have 3 unit conversion factors. 24 seasons, what you start off with. 1 season is 22 episodes. 1 episode is 44 minutes. So, solution. 24 seasons is what we start off with. How do I know that I start off with 24 seasons? It's because that's the only one that isn't a conversion ratio. See, like each season has episodes, but I started off with 24 seasons. So what I do know is that 1 season is 22 episodes. I'm trying to get down to a time measurement, because if I have a time measurement, then I can convert that to days. So for every 1 season, there are 22 episodes. And that cancels the seasons. If I stop now, I'll figure out how many episodes I watched. But what I want is I want days of my life that were wasted. So I will say that there are one episode is 44 minutes. And that cancels the episodes. And so now I have purely a time measurement. Now I know how many minutes of my life were wasted watching SVU or spent gloriously watching SVU, depending on your opinion. Once they got rid of and then also big fan, like Alex was a good DA. I liked Casey Novak more. Casey Novak was my jam. Right? She's great. She also reminded me of Haley Williams from Paramore. So, and I love Paramore. It's a great band. Highly recommend if you haven't listened to Paramore. But I don't want minutes. I want days. So the only thing I know, I mean, you might be able to know how many days, minutes there are in a day, but I don't. So I'm going to first convert this to hours because I know there are 24 hours in a day. So there are 60 minutes in 1 hour. So I'm going to put the minutes in the denominator so that it can cancel. So 60 minutes to 1 hour. And that cancels the minutes. Now I know how many hours I've spent, but I want to convert that to days. So there's one last unit conversion. This one's a very long one. This one's a long one, but it's fun. I think this is hilarious. Maybe I'm alone. So there are 24 hours in one day. The hours should go in the denominator to cancel it in the numerator, and then 1 day. Now the hours have canceled. And I'm left with just days, which is exactly the unit measurement I wanted. I wanted to know how many days were used. So we're done now. We've done all the unit conversions that are necessary. So that means at the end of the day, we have up in the numerator, we multiply across. So 24 times 22 times 44, then times 1, but that doesn't change anything. Then in the denominator, I have 60 times 24, which is 23,232 divided by 1440. Wait, let me make sure. What?
That's the number.
Okay, because I decided to change it from last time. Last time I did 45, but then I did a little bit of analysis, saw that was a little closer to 44. So
we rewatched every single episode again.
I went on to IMDb and saw every episode said like 45, 46, 44, 43, and so on and so forth. And if you do this, you get 16.1333 repeating. If we're going to round to 2 decimal places, which I didn't specify, but I didn't want to give us carpal tunnel in the problem statement. So looking at the second digit, so 16.13. So 16.13 days wasted. That is 16.13 days of my life that I could have been outside talking to girls, whatever, something like that. But no, I decided to stay inside. Granted, I was multitasking. I was studying for my GRE at the same time, but either way. So yes.
On this calculator, is that a function? Is that a-
Ah, great question. Great question. If you bought the calculator that I mentioned, so there's a button. So if you bought the calculator that I mentioned, or if you buy Casios, they typically have a button that says S_D. What that means is standard to decimal form. If you press that button, it will convert it from a fraction to a decimal, and then if you press it again, it'll convert it to an approximation. Because sometimes our decimal expansion is way too long, and or it'll write it as like 16.13 repeating. And if you want a full out expansion, just press it again. So that is because the calculator likes to give it to you in exact form, which would be the fractional form, and in the decimal form.
Where is
It's usually right above the AC button, the clearing button. So yes, that is the that is something I really like about the calculators. It gives it as a fraction first, and then it gives it as a decimal. So My first year of teaching, I actually switched this to How I Met Your Mother because I was very like I just watched the How I Met Your Mother and I was very upset by the ending. So I felt cheated. And then 2 years ago, I watched all of Lost, and that's what I used because do not watch Lost. It's a waste. It's a waste of your time. Too many questions unanswered. Such a disappointment. Such a disappointing last season. Oh my God. But now you can figure out how much time you've wasted on different shows. It's a great concept. Grey's Anatomy. That's another one of my shows that my mom and I like to watch. But after I left home, that one I stopped watching. Adorably, my mom and I were big into Dexter. That was another one. Ending of that one. Terrible. No, I didn't finish Once Upon a Time. Was it good? Like good ending?
I loved it.
Okay. So I should change this one. Instead of talking about the negatives, I should talk about the positives. Highly recommend Good Place if you haven't seen that one. Great ending. Great ending. Anyways, I'm getting sidetracked. Your guys' fault, not mine. But anyways, so that's one example of like a silly situation, but you can also do this in a multitude of ways. So I think I'll do two more. A full 180 gallon tank has a hole in the bottom. And starts leaking at a rate of 1.1 quarts per minute. How many gallons will be left after 8 hours? This one's a little tricky at first because the question ends up being, where do I start? What do I start with? What unit do I start with? Because do I start with 180? It's not exactly. Because the 180 is how much is in the tank. I want to know how much is how much is gone. If I figure out how much is gone, then I can figure out how much is left. Because how many gallons will be left in the 180 gallon tank? So, usually speaking, the correct thing to start off with is the thing that isn't a unit conversion. So there's two things that aren't unit conversions. There's the 180 gallons, and then there's the 8 hours. Those are not unit conversions. Those are just static numbers. So you can start off with 180 gallons, but you'll find out that you get stumped quite quickly. So we instead start with the 8 hours. Yes. So what? How many gallons will left? Yes, there should be a B. Thank you. Testing you guys on your English skills as well. So I bring that up because like there's two static numbers. There's the 8 hours and there's 180 gallons. It is okay to mess up, right? You could start with the 180 and get stumped. Try the next avenue. Try 8 hours and see if that gets you farther. In my experience, the students who are willing to try different avenues when they get stumped instead of just keep going the same route over and over again are the ones that succeed the most. So being a mathematician is being okay being wrong. Mathematics humbles you very quickly. I think I told you guys earlier, the average in my class at one point was a 15 out of 75. We all did horrible. And that is okay. That is a learning process. I learned the most personally, I learned the most from screwing up. When you screw up, you don't usually make the same mistake twice. So it's okay to get it wrong. It's okay. Just erase, start over, or crumple up a paper, try a new one. So 8 hours is the correct way to start. I encourage you to see what happens when you try 180 and see how you get stumped. But
Wait, why is it?
why is it the right way to do 8 hours instead of 180?
Yeah, how do you know?
I didn't. I tried 180 at first and I got stumped. So I tried to do 8 hours and that ended up being the right way. So I have two avenues to go down. That's not many choices to choose.
So you're pretty much getting.
You're gambling, but I mean, as we've seen with these problems, I mean, I'm explaining them, so they're taking longer, but like when you're on your own, these problems usually end up taking, let's say, anywhere from about 3 to 10 minutes. So if you get stumped at like the 2-minute marker, go back, try again, try a different thing. It's not too much of a time investment. So this is 8 hours. The only other rate that I'm given is 1.1 quarts per minute. So hours isn't going to help me here. So I need to convert those hours to minutes. Does that make sense? Because it says quarts per minute. If it said quarts per hour, then I might be fine. But as it's quarts per minute, I'm going to convert this. There's 1 hour in every 60 minutes. And now the hours cancel. But that's not what I want. I need to know how many gallons were lost in 8 hours. So, but I know that there's 1.1 quart every minute. So for every 1 minute, which I'll put in the denominator to cancel it again, there is 1.1 quart, which is abbreviation of QT, which I think is pretty cute. And now here's the question. You guys know how many quarts there are in a gallon? 4, because America. There's 2 cups in a pint, 2 pints in a quart, 4 quarts in a gallon, because America. Once again, we can't just have milliliters and liters and things like that. That'd be too easy. That'd be too easy. But the reason why we're going to add another unit conversion, the quarts, the minutes cancel, but now I just have quarts, which is a liquid measurement, which is good, but it's not good enough because I want gallons, because my original thing was in gallons. I have 180 gallons in the tank. I want to know how many are left. So in order to subtract off what's left, I need it in gallons. So there are 4 quarts in every gallon, and you do not need to memorize that. Once again, there should be a unit conversion chart. You can even ask Siri how many quarts are in a gallon or whatever. That's fine. On the exam, I will provide you every necessary one on a sheet on the back. So there will be a sheet that has every needed unit conversion that you need. So 4 quarts to every 1 gallon, and that will cancel the quarts. And now I have gallons. So up in the numerator, I've got 8 times 60 times 1.1. And down in the denominator, I just have a 4. Multiplying the numerator out, you'll get 528 divided by 4, which ends up being 132. Exactly. And that's gallons lost. That's not the answer. When it comes to word problems, you always want to reflect on your answer, not reflect on why you're taking mathematics in the first place, but rather, did I answer the question? And if the question said how many gallons were lost, this would be the answer. But it's saying how many gallons are left. So this is not the answer. The amount left is 180, the original amount, minus 132, which is 48 gallons left. And yes, this was a very, very contrived example, because who the hell measures in quarts per minute? Like, who the heck does that? But like, you can see the application here. Like, let's say you're working on an oil tanker and there ends up being a leak in one of the pipes. Things are leaking out into the ocean. you need to know how much is leaking out to figure out how fast you need to act, right? I mean, granted, if it's leaking into the ocean, you probably want to act as fast as possible. Or you can be Dawn dish soap and cover the duck in oil so that you can show how efficient your soap is, right? Because that duck is dirty. That means they had to put it into the ocean to grab it. Anyways, I always think that's funny. Anyways, so this is something that could actually end up happening in your real life. I mean, you have to figure out how many gallons are leaking, but you can figure that out based on how many gallons are there and how much time has passed. Anyways, I'm getting sidetracked. We'll do one more, and then we'll start up 1.4. So this is another real life application of unit conversions that actually happened to me, because I think I told you guys I originally was teaching in Ohio. And then I got the job here and I needed to move across the country. And sadly, they did not reimburse me for my travel. Some people do, some companies do. I guess CSN did not want to. That's okay, not better. So I needed to figure out, I needed to budget it. I needed to budget how much money I needed to save for the trip. So you need to move across country. You are moving for work to a city 1,225 miles away. If the moving truck rental is $1,400, which is now a low estimate from what I've seen, which is ridiculous. But anyways, and the truck gets 15 miles per gallon. How much will the move cost when you estimate that gas will cost $3.30 per gallon? This is a loaded problem. It's a loaded problem because this isn't just a simple unit conversion, because we're going to have to do two things. The moving truck rental, I'll let you write that down before I talk. Now, this is a simplified version of it because I was traveling across the country. I was driving from Ohio over to here. And so it was more than just gas and the rental. I also had to think about food and hotel rentals. I mean, granted, I could have slept in the car, but I don't recommend that. If you could avoid it. Or you could just kind of plan it out so that your bed is available in the back of the trunk. But anyways, I'm sidetracked. So there are more variables that need to be gone into here for it to be accurate. And so just keep that in mind if you're trying to do this. But this is a good estimate of how much your rental truck is going to cost you. So, solution. First things first is that the total cost is going to equal the rental plus gas. The rental is static because I rented it for exactly, I think our trip was 5 days total, because we had our dog with us and he had to take several breaks. So this is 1400, that's fixed. We don't need to calculate that at all, that's already given. But gas is dependent upon a unit conversion. So we'll do that one here. So we've taken care of this measurement. We've gotten rid of that. Sometimes it might help to like underline the things that you've already taken account of. So what number for the gas? What number should I start off with? Take a second to think about it yourself. Don't answer it. Think about what you'd start off with. If you're stumped, I'm going to give you a hint, just a little bit. There's three numbers that are listed, right? There's the 1,125, there's the 15, and there's the 330. Only one of them is not a unit conversion or a unit factor. That's 330 per gallon. So that is a unit conversion.
Mile per gallon?
That is also a unit conversion because per. The 1225 is a static number. That is how many miles I have to travel. That is how I know I'm starting off with that. Now, it's not wrong to do so. You can all, like, I mean, one could argue that's 1,225 miles per trip. So you could write it as a unit conversion, but I'd rather just start off with that 12,000 or 1,225. So 1,225 miles. And that's how I knew to start off with that, because that was the only one that wasn't per something. And so we're starting off with miles. We need dollars. So if I can convert that to, which one should I do first? Which one of these has miles in it? The first one. So there are 15 miles per gallon. So that's 15 miles for every 1 gallon. So 15 miles should go in the denominator to cancel it for every 1 gallon of gasoline. As another useful tip, just in terms of if you're actually planning on doing this type of thing where you're moving across the country, always do an overestimation. So like, yeah, you might be going through Texas. When my parents were living there, their gas was $2.20. And I hate them. I hated them for it. It's here way cheap, way more expensive. But anyways, now we have gallons of gasoline, and that's it. But we want $3, like we need it in dollars. So it's $3.30 per gallon. So for every 1 gallon, it's $3.30. So the gallons should go in the denominator. So 1 gallon is $3.30. And because America, we put the dollar sign first. Drives me nuts. I always forget to write it. Like if I remember correctly, in yen, they put it at the end, right? And for euros, they put it at the end. Do they pesos, do they put it at the end? Or is it? It's yeah, the end. So we're the only country that does this that I can think of. It's stupid. Why can't we just put the dollar sign at the end? I don't know. Yeah, because we're free. We got our freedom toast, we got our freedom fries. You don't need any of that stuff. All right. And that leaves me with just dollars. So we're good. We've got dollars, which is exactly what we need. So that's going to be 1,225 times 330 up top. And then down in the bottom, we got 15. And just to save on time, this ends up being $269.50. So $270 in gas. Right. And so the total then, we've got both. The total will be 1,400. So 1,400 plus 269.50, which is $1,669.50, which I forgot to write the number sign, but luckily I had enough space. And that's my answer. If anybody knows how many any other country that puts their currency measurement first, please let me know. I'm curious. Yes. Peru? They do? What's the unit? What's the What is it?
Solis.
So,
It makes sense.
gotcha. So, okay, so we're not the only ones. We're not the only ones, but we're one of the very few. All right, any questions on that? Yes. Mhm. So yeah, this one was like, because it's asking for the total cost of the travel, that's why we needed to add the 1,400. But if it was just asking for how much is it costing gas, then we just write the $269. So that's a very, very good point to bring up. So remember, read these questions very carefully. Because on your homework and on the quizzes, they won't see the partial credit. Now, granted, you can always email me and say, Phil, is there any partial credit that's available? Always show me your work though, if you do that. That way I can see what's going on and I can give you partial credit. But on the exam, the good news is I'm grading that myself, so I can see where you made the mistake. So if you wrote Boxon 270, that's usually worth about, I'd say, probably 7 out of the 10 points, if that's a 10-point problem. So not as bad as a 0, right? Okay. Anyways, all right, we're going to start up right triangles and trigonometry. Section 1.4, which is right triangles and trigonometry. Trigonometry. Say it out loud every single time because I can't spell. Before we do this, I have two. So that's going to take me a while. Okay. Oh, got that. Jeez, this was a long section. What was I thinking? Okay. So a little review. Preface. The first thing is the additive property of equations. So this is so we need to do this because we're going to talk about the Pythagorean theorem, which is going to need us to solve equations. And in order to do that, we need to talk about a couple things. The first thing being the additive property of equations. And what that says is that if you add or subtract, so add/subtract a quantity from both sides. I'm going to underline that both because it's very important that it has to be done to both sides of an equation. If you add or subtract the same quantity from both sides of an equation, the equality remains balanced. Same thing is true for multiplication and subtraction, or multiplication and division by numbers. So note, the same is true for multiplication/division by numbers. So if you multiply these both sides of an equation by the same number, it stays balanced. If you divide both sides by the same number, it stays balanced. So what do I mean by balanced? I mean that the solution to the equation does not change. If you add something to one side only, that will tip the balance and the equation will no longer be equal. If you multiply one side by one number and only one side, it becomes unbalanced. Like you remember those those old school things. Maybe your grandparents might have one, those balances, those scales. And you put like 5 pounds over here of feathers and 5 pounds of bricks, and they end up being the same. So that's what I like to think of an equation as. It's a balance. And if you only add something to one side, it'll tip the balance. So you have, if you want to keep them level, you have to add the same thing to both sides, or you have to double both sides. So as an example of this, you see it in action. If I have 2x plus 5 equals, let's say, 15. The way we solve this, we want to get rid of the things farthest away from us first. Those are our friends that we don't really know very well. We can't trust them to help us clean up our party. But the people right next to us, we can assume that they might do a little bit of cleanup if they're a good friend. So we want to get rid of that plus 5. In order to do that, we have to undo it. So if it's being added, we need to subtract it. So we're going to subtract 5 from both sides. And that'll cancel it on the left. And the equation will remain balanced because I've taken 5 pounds off both sides. So it doesn't change the balance. And so now we end up with 2x equals 10. Now I want to solve for x. I want to get myself, just me in my house, so that there's no question I wasn't supposed to invite anybody over. So the 2 is being multiplied into the x. So to undo the multiplication, I do division. I divide both sides by 2. And I get my answer, which is that x equals 5. That is what I mean by trying to solve an equation. We're trying to get it down to x equals blah or blah equals x. So what? That is how we will solve an equation. You want to get rid of the things outside us first. This is called a linear equation. We won't get into anything really higher than that, but there are more things later on in your mathematical career if you decide to continue. So we're going to do 2 examples, and then we will we move on from there. Example, solve. Part A will be 7 equals 5x minus 2, and part B will be 12 plus x equals 15. So I did these ones deliberately. I chose these problems specifically to break us out of our comfort zone here. So yes, normally speaking, the x is on the right, the left-hand side. That's the way we like to see it, but that's not the only way it can be presented. Saying 5 is equal to x is the same thing as saying x is equal to 5. You can do it in either way. So with this one, 7 equals 5x minus 2. I want to get the x by itself. So what should I do first? Add 2. Very, very good. I'm going to add 2 to both sides to undo that subtraction by 2. And that'll give us 9 equals 5x. At which point, now I just need to get x by itself. So since the x is being multiplied by 5, I will divide by 5 to cancel it and get that 9/5, which we can't simplify any further than that. I mean, we could write an approximation. We could, or it won't be an approximation, the exact number. You can get one. You could write it as 1.8, but I'd rather it let's be 9/5 is equal to x. You can leave it like this, or you could write it as x equals 9/5. However you want to write it, if it feels better you to write it as x equals 9/5, that's fine. But know that 9/5 equals x is still equivalent. Yes.
Are we gonna have to write an answer like this on one of the online?
I believe that most of the problems online, they end up being nice whole numbers or decimals.
Okay.
So, but just for this one, I didn't intend this to give you a nice number, but I wrote -2. I meant to write +2, but oh well, it's fine. Fractions are okay. They're people just like you and me, right? We deal with them all the time. So it's okay. But yeah, like on the homework, it usually ends up being nice numbers, or decimal numbers. So that's part A. Any questions on part A? Part B is a little tricky at first. 12 plus x equals 15. We want to get the x by itself. But I've got a 12 that isn't being added or subtracted. Technically it is though, because 12 plus x is the same thing. Same as x plus 12 by commutativity. 2 plus 3 is the same thing as 3 plus 2. So you can reorient it to know that 12 is being added. So you can subtract 12 from both sides to undo the adding of 12. Does that make sense? Does anybody have any questions on that? Because that looks weird at first. Yes. Great question. Great question. The answer we know. So if it was 12 minus x, that is not so subtraction is not commutative. So 5 minus 6 is not the same thing as 6 minus 5. They differ. So one way to think that there's many ways you could argue about this. You could say that this is the same thing as negative x plus 12. And that's the way I would do it, because you could rewrite this as 12 plus negative x. And that's the reason why you can switch it around like that. Because now you're talking about addition, and addition is commutative, and you can flip it around. Or you could see it as that's a positive 12 on the left-hand side. I need to get rid of it, so I need to subtract 12. However you want to do it, but great question to bring up. Because subtraction is not commutative, we can't flip it around like that when it becomes minus x.
Wait, so if we were saying from this 12 minus x, would we still, to cancel out, would we add 12?
We would subtract 12. So if it was 12 minus x equals 15, we would still subtract 12. Because that's a positive 12 there. And to undo that positive, we need to subtract it. Great question, guys. That's a very important question about these things. So x is equal to 15 minus 12, that's 3. And luckily for us, we don't need to divide or multiply because it's just x already. Yeah, I totally wanted to draw a parallelogram. There we go. All right, any questions on that? All right, we will we might need to do a little bit of editing of our calendar, because I don't know if we'll be able to finish all of the material before the exam. But I'll keep posted on that. The next thing I want to talk about, the other review, is the square root property. Which says the square root of x squared is equal to x, quote unquote. Just in case there's a secret math teacher out there, if like maybe one of you guys is a professor at UNLV or at NSC or whatever. So if any of you guys are that, I'm putting that in quotation marks because that's not 100% true. Mathematically speaking, technically, so don't write this down because it's not going to be important for us in this class. Technically speaking, the absolute value of, or the square root of x squared is equal to the absolute value of x, technically, because if you're looking at it as a raw mathematical object, there are two solutions. There's positive x and there's negative x that work. But we're going to only be dealing with this in a physical sense, in a real world sense. And so we're not going to get any negative answers. Like we're going to be using this to solve for the missing side lengths of triangles, and triangles can't have negative side lengths, right? Can't have -5 as your side length. So for us, the square root of x squared will equal x. Just like if you're curious though, there is a little bit of mathematics around that. So essentially, this means so square roots undo squared. So if you have a quantity squared and you square root it, it undoes it. Just like multiplication and division undo each other, multiplying by 3 and then dividing by 3 cancel each other out. Squaring something and then square rooting it cancels it out. So
Wait, can't you just do absolute value and then you can?
like yes and no. Yes and no. So like I'll show you with an example. Solve what do you do? A is equal to x not A is equal to A is x squared equals 64 and B is x squared plus 19 is equal to 40. Let's do 40. So part A, x squared is equal to 64. We've already got the A by itself, but we need to have x equals, not x squared. So what we do, and this will keep the equation relatively balanced, and I'll explain why in a second. We're going to take the square root of both sides. Now, you may have seen that technically speaking, I need to put a plus or minus. And that's fine if you do so. That's the more correct answer. But for us, so technically, plus or minus the square root of 64. But we're not interested in the negatives. We're not interested in the negatives because we're going to be dealing with these things purely in a real world context. And there's not going to be things that are negative. We're not going to have negative 5 seconds. We're not going to have negative 5 feet. So because the quantities we're dealing with have to be positive, we're just going to ignore that. Mathematically speaking, there are 2 solutions to this. There's 8 and there is negative 8. But in a real world context, the only answer is 8 because you can't have negative 8 feet. So doing this, the square root and the square cancel, and then x is equal to 8. That is our solution. And you can use your calculator, and I encourage you to, because a lot of the times we're going to get irrational numbers, meaning that these are going to be decimal numbers. Which once again, you're going to press the S to D button, S double arrow D, and that will give you the right things. So B, x squared plus 19 is equal to 40. Same concept. Fact is, we want to get rid of the people we don't trust to help us clean our house first. So we need to get rid of that 19 first. So we're going to subtract 19 from both sides. We get x squared is equal to 21. Or x squared is equal to 21. And then, so we have x squared, but we want x. So we'll take the square root of both sides to cancel the square and the square root. And get that x is equal to the square root of 21, which is approximately, it's rounded 2 decimal places. They will tell you in the problem how many decimal places they want you to round to, but I'm going to do that. So square root of 21, which then I press the S to D button, and it gives me 4.582. So equals 4.58257, on and on forever. So approximating that to 2 decimal places, that would be 4.58. How did I, yes. So if we're rounding to the second decimal place, we look at the number to the right of it, it's 2, which is less than 5. So we're going to round down. So we get 4.58. If it was 4.586, then we would round up to 4.59. Does that make sense? So if the number is 5 or greater, you round up and you just bring the decimal up 1. If it's below 5, then you round down, you just drop everything to the right. All right, any questions on that? Oh, you said, how did you get, you said, how did you get?
I was trying to figure it out.
Okay, did you get it all done? Okay, excellent. Okay, guys. So we'll pick up next time on Thursday with the rest of 1.4. This was all like review to set up for the Pythagorean theorem and for trigonometry. And then we'll go from there. Okay, guys? If you have any questions, feel free to email me. Otherwise, you guys have a great rest of your day, and I will see you on Thursday.